When we say that there's more current flowing through a wire or less current, what does that actually mean? Does it mean that there's like the speed of the charges moving through the circuit is different? Or does it mean the quantity, that there's like more charge somehow moving through than there was before? Take a minute to right now to like write what you think down below before this whole thing begins. And if you're an electrical engineer, please check me on this. This is just me like coming to understandings. I'm not an engineer, but I'm like nerdy enough to like research and try to figure this stuff out. So my hypothesis is that it is not this, right? We say that we've got a wire. When we think of 1 ampere, we think like very few charges are moving. And then when we think of 100 amps, we think a whole bunch of charges are in here moving. But the very simple fact that when we apply an electric field across a conductor, it's made of a crystalline lattice. There's a sea of electrons that are free. When we apply the field to that conductor, the entire sea is gonna move. It doesn't matter if like it's 1 ampere moving or if it's 100 amperes moving, all of the charges are moving. We don't have like little pockets of charges that are like hanging out and chilling that sometimes don't move, because by the very physics of applying a field, every charge is gonna move, right? You apply a field to any electric thing, it's gonna move, it's gonna have a result. So all of the charges have to be moving the entire time. So if they're all the same quantity as moving, it can't really be about more charge moving. It has to be about something else. And the only other thing that it could be is speed. But then when we think about it, we've got a 60 hertz electrical system, right? We've got a certain rotation that's happening inside of a generator that's creating an oscillation of charges down the field. And it's 60 hertz, right? It is 60 times, 60 full cycles. 1, 2, 3, 60 of those every single second. So we have a speed limit, so to speak, on all of this current. So it's not like these oscillating charges are like oscillating faster. They can't be oscillating like more cycles a second, otherwise that's higher hertz, right? That's 100 hertz, 300 hertz. We're pinned to 60 hertz. So like what the hell is actually happening, right? If it's not more charge and if it's not more oscillation, like how is anything changed? Well, first, I think it's really important to understand like how we define current. We have these two equations, algebra, calculus, doesn't matter how you look at it, but we have a certain quantity of charge per second. So if we take a slice in time, a cross-sectional area of something and put a sensor there, and we see a certain amount of current flow through, we're calculating the quantity of charge moving per second. So that is not time, that's not speed, that's volume, it's quantity. Calculus is, just differential version of the same equation. It's change in charge over change in time, but you still have coulombs per second. So let's look at this whole idea of looking at the cross-sectional area of something versus looking at the volume of something, because there's a huge difference. When you have volume, you have length, you have distance. You can look at time. You can say how much has something moved or how many of certain things have moved over time. You can't do that with a cross-sectional area. With a cross-sectional area, you can just look at how many things are like deposited onto the plate over the whole area. So when we are understanding this understanding of current, we're looking at the quantity of a thing, and it's because we're looking at the cross-sectional area only. We're not giving any third dimension any length or time. And once we start doing that, we have to evaluate the density, and we can now evaluate what kind of distance was traversed so we can understand a speed as well. And so I'm here to like spoiler alert, I think it's both. It just depends on if you're looking at volume or if you're looking at area. So there's current density. This isn't like a lesson on drift velocity and current density. Again, not an electrical engineer, but these are things to look into to have funsies later if you're just a nerd like I am. Current density is essentially how densely current is across an area, a cross-sectional area. So if we've got this little slice, how dense is the current on there? When we have drift velocity, we're looking at the actual volume. We want to know the number of electric charges, the quantity of coulombs of charge per unit volume. So it's a different story. We're able to see the velocity, the speed. Not the quantity, the density. We're looking at the speed in which something's happening. So we have this thing called drift velocity. And it just means that when we, say we apply like 12 volts, a 12 volt electric field across a conductor, there's gonna be a certain speed that those charges move. But if we take 1,000 volts and apply it, we're gonna have a different speed. We're gonna have a different drift velocity. Now, if we oscillate a high drift velocity at 60 times a second, it just means that charges are gonna go shoo, shoo, shoo. But if we have a low drift velocity, we have a low, 12 volts, small difference potential, it's still the same 60 hertz, it's 60, cycles every second. It's just that there's not a lot of speed from getting to side A to side B during that oscillation. It's still getting there. It's still the same clock, the same time, the same oscillations happening. I would say it's more like the intensity of the motion to get through the oscillation. That's what's changing. So if you have, like say we got a pendulum with a little ball, this would be like 12 volts, right? We've just got this smooth, chilling oscillation. When you have 480 volts, you're looking like boom, 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 boom. You have this intensity behind the motion between those hertz. So that is what drift velocity is all about. And drift velocity is really huge because once you start understanding the electric field side of this, there has to be a difference of an intensity, right? If we didn't have 60 hertz, if we just said, we're gonna do an experiment and we're gonna take a clamp-on ammeter and we're gonna put it over a conductor and we're just gonna put a field across boom, really fast. Let's see what happens. That thing is going to detect a massive change in current, right? Because that's what the expanding and collapsing magnetic field, that's how our clamp-on ammeters work when we put them around a conductor. It detects the change in current and how strong of a change that is. So when we apply a massive voltage, there's gonna be a huge velocity, a huge sudden change. And that magnetic field that generates is gonna be huge. So our current's gonna read, whoa, big, right? But if we have a very small voltage, small difference of potential that we apply, the multimeter is going to read small because it's not as much of a field. It's not as intense of a change in that current. That's crazy. I just the coming to that understanding. And again, engineers, physicists, whatever, tell me if I'm wrong. Any of you nerds too, go chat GPT, do whatever the hell you guys do. But I would love to know in the comments if this is your understanding of it as well, or if you think that I'm wrong, if I missed something, I would love to know. But I think it's just a mind-blowing thing for me to understand. It's not the speed of charges that's changing. They're still 60 times a second. There's not more charges that are just chilling in the material that all of a sudden start moving when we have a high amperage. The whole body, the full sea of charges is moving the whole time. It's just the speed at which they go through their 60 hertz oscillation that changes, and that's why we say there's more current. And the cooler thing about that is the word intensity actually makes more sense now. So we have this intensité de courant. I'm not French, I don't know how the fuck to say that. But that's what, the word intensity, that's where I comes from in current. It's this French term. That just means the current intensity. It means how intensely is the current moving. It's not the volume, it's not the quantity that's moving. The speed within the greater quantity. Sure, if you move more things in a certain area, if you've got a conductor and you just take a chunk of it, a 3-foot chunk of it, and you pass 480 volts, way more is going to move through that because it's just faster intensity. So more charge, essentially, yes, the quantity would change because we're just moving more charge per second than just, this little bit per second. So it is volume, but it's not because there's more charges coming from somewhere. It's the same charges. They're just moving with greater intensity based on the different field that we have applied. That just blows my mind. So if you guys got something, can't read to wait the comments on this one. Love you, crazy fuckers. See you in the next one.